Hey, here we are. This is where it all comes to a head, and we're going to use what we've learned to answer the question, how do I use the properties of inequalities to solve, then correctly write the solution? So this is where the previous two videos are, we're going to use that information and techniques in this video. Here we go. Solve the following inequalities. Solve, graph, write in set and interval notation. Okay, so to solve, I have to add 6 first. Let me change that. That's the addition property. Ooh, that looks bad. Okay, so that gives me 3y is less than 9. Now I'm going to divide by a positive 3. That's the division property. And I get y is less than 3. In set notation, well, let's see, I solved it, so let's graph it. Let's do it in the order that they give us. Here's 0, 1, 2, 3, and -1, and then open dot, because it doesn't include the endpoint, and so I get all y's. This is set notation, such that y is less than 3. I'm going to make a note that's set notation. And then in interval notation, this is going off to the left forever. So that implies we have a negative infinity. And with a negative infinity, we always use a parenthesis. That is a parenthesis. And then we're going to go to 3, but we're not going to include it. So we're going to use a parenthesis. On number 2, I have a little bit more work to do. I'm going to subtract 4x from both sides, and then I'm going to add 3 to both sides. That gets my variables on the left, my non-variables on the right. So I have x is greater than or equal to 5. When I graph that, here's 0, 2, 3, 4, 5. Here's 5. I'm going to use a closed dot, and then I'm going to go off to the right. So remember, my smallest number goes on the left of my interval, so that's a 5, and then it keeps going off to the right. So that means I'm going to go off to positive infinity, and with infinities I always use a parenthesis. Right? We can also solve inequality application or word problems, where now we're going to translate, solve, graph, write in set and interval notation. Whew, that's a lot. Here we go. The sum, that implies we're going to be adding 3 times a number. Well, that's 3x. So what are we summing? 3x and 4. So there we go, 3x plus 4. Is at most. Is at most. That means it can be equal to or it can be less than. So we're going to get our translation is 3x plus 4 is less than or equal to negative 16. And now we're going to solve by subtracting 4. That is the subtraction property. So that means 3x is less than or equal to negative 20. And then I'm going to divide by 3. So x is less than or equal to negative 20 over 3. I'm going to graph it. I'm going to graph it out here for you. Here's 0. Negative 20 over 3, that's almost negative 7. So 1, 2, 3, 4, 5. Here's negative Here's negative 6, and here's negative 7. So we're like right here. And then it includes it, so we're going to use a closed dot, and it's less than. So left is less, left is less. So in interval notation, it's going to be all x's such that x is less than or equal to negative 20 over 3. And, sorry, that's set notation. Can't remember what I said. Set notation. And interval notation, it's going to go off to negative infinity. Always use a parenthesis. It's going to come up to negative 20 over 3. It includes it, so we're going to use a bracket. Is at most. It can equal negative 16, but it can be less than negative 16 as well. Okay, why don't you hit pause and try both of these. Oh wait, no, I'm sorry. No, well, I'll solve these with you. Here's negative 4. We're going to divide by negative 4, divide by negative 4. What happens when I divide by a negative? Division by a negative. I have to flip the direction of my inequality. X is less than negative 3. So here's my number line. Here's 0. Here's negative 3. Open dot to the left. So it's all x's such that x is less than negative 3. That's set notation. And interval notation says it goes off to negative infinity because it just keeps going and going and going. Comma, negative 3 doesn't include it, so I'm going to use a parenthesis. That's the interval notation. Okay, I'm going to divide both sides by a positive 4.2. Do I flip the direction of my inequality? I'm so hoping that you're saying no. So this says x is greater than or equal to, I believe that's 2.5, negative 2.5. Nope, it's negative 6.9. Thinking of a different problem. Negative 6.9. Okay. Graph it. I'm bigger than it. Here's 0, 1, 2, 3, 4, 5, negative 6, negative 7. Okay, so I'm right here. And then it's going to go to the right. So it is in set notation. It is all x's such that x is greater than or equal to negative 6.9. And then in interval notation, it will be bracket negative 6.9. It's a bracket because this includes that equal sign. And then off to positive infinity. There you go. All right, let's keep working. This one here, we have to distribute. Then we're going to have to combine like things if needed. We're going to have to move. We're going to have to do a lot to this. So the problems are going to get increasingly harder, more complex. So here we go. I have negative 6 times negative 4. I'm using the distribution property. Put a little d here. And I get 24x minus 18. That's the distribution property is less than, can you tell it's an 18? There we go. 20x plus 6. Now I'm going to subtract 20x. And I'm going to add 18. So I'm using addition and subtraction property all in one step. I think you guys can handle that. and I get 4x is less than or equal to 24. Then I'm going to divide, and I get x is less than or equal to 6. Then I'm going to graph it. Here's 0, 1, 2, 3, 4, 5, 6. I'm going to use a closed dot and a line to the left. Set notation. All x's such that x is less than or equal to 6. Interval notation. It's going off to the left. So I have a negative infinity, which requires a parenthesis, to positive 6. It includes negative 6, so that's a bracket. All right, on number 2, I'm going to multiply both sides by negative 4. Okay, so when I do that, whenever I multiply by a negative, what do I have to do to flip the direction of that inequality? These are going to cancel. So I have negative 32y is less than or equal to, look what I did there, I flipped, negative 5y plus 9. I'm going to add 5y to both sides. That gives me negative 27y is less than or equal to 9. And I'm going to divide through by a negative 27. And I'm going to flip my inequality symbol because I'm dividing by a negative number. And I'm going to reduce. So on a number line, here's 0, here's 1, here's 1/3. And it's going to be a closed dot and off to the right. So it is all y's such that y is greater than or equal to negative 1/3. That's set notation. And interval notation says it includes my endpoint. That's a bracket. My endpoint is negative 1/3. And then it goes off to positive infinity. All right, why don't you hit pause, try both of these, and then come back and see if you got them right. Okay, I'm going to go ahead and start working them. I'm going to multiply both sides by 5. And when I do this, this side cancels because this is considered like that in parentheses. So negative 15x is less than or equal to negative 4x plus 22. I'm going to use the addition property, 4x, 4x. That gives me negative 11x is less than or equal to positive 22. I'm going to use the division property of inequality. I'm dividing by a negative number, so that means I have to flip my inequality symbol. I'm going to graph it. Here's 0, 1, 2, negative 2. And my line's going to go off to the right. That's an infinity situation. Okay, my smallest number is going to be negative 2, and it includes it, so it's bracket, negative 2, positive infinity, parenthesis. In set notation, I'm just going to add it up here. Looks like that. All right, how'd you do? Number 3, negative 15d plus 22. This is a distributive property. 6d plus 42. I'm going to subtract 6d, and I'm going to subtract, well, I don't know what I wrote there, but I didn't write. How's that? Should be plus 35. And I'm going to subtract 35 from both sides. Okay, and I get negative 21D is greater than 7. And then I'm going to divide by negative 21. I'm dividing by a negative, so that means I have to flip. I'm going to reduce that fraction. I'm going to write it in, here's 0, here's negative 1, here's negative 1/3, open off to the left. So set notation, I'm going to write set notation up here. This is going to be all D's such that. And then my interval notation is parenthesis negative infinity, comma 1, negative 1/3 parenthesis. Okay, let's try this one. I'm a web advertising account manager. And then for each account, you're going to earn $15 plus a nickel for each hit on a site. Okay, how many hits are needed for an account to earn at least $500? So this would be a good idea if you're going to go into sales. You want to know how well you have to perform. What are your targets? Okay, so my income is going to be $15 plus a nickel for every hit. I'm going to call that H. And I want to earn at least. So that means it's going to be 500 or greater. So that's going to be greater than or equal to $500. I'm going to subtract 15. And I'm going to divide by 0.05. So that means my hits have to be, hold on, I need to calculate this real quick. I need 9,700 hits on that account to get $500 from it. That's a 7 here, folks. Okay? All right. So now based on the above information, how many accounts do I need to earn $3,000 or more? Okay, so if one account gives me 500, so 6 times an account, I'm sorry, not 6. It's actually going to be the answer, hint, hint. So 500, if I target 500 per account, okay, I want $3,000 or more. I want it to be greater than or equal to $3,000. So the number of accounts needs to be at least 6 accounts. So that means the number of hits I need in total is going to be 6 times the hits per account, 9,700. And that's going to give me 58,200 hits. Okay? All right. These are the problems that we're going to be working on. This will be our daily assignment in class. So there's quite a few problems. The top of the day will probably be a little bit shorter, and then we'll get started and do these. This page 40, this is writing in set notation and interval notation. All right. Okay, thanks for listening.